guys could open to page 27. We'll take a look at the calendar. I'll say this is a very important look at the calendar because what's happening next Thursday or this coming Thursday? This coming Thursday, the projects are due. I have gotten 4 projects so far. I think I just saw a few go into the folders now, so that's good. But the projects are due this coming Thursday. If you do not hand the project in to me this coming Thursday, every day that it's late, it's 5 points off. So if you miss it on Friday, that's 5 points. If you miss it Monday, it's 5 points. I'm not saying it's every Tuesday, Thursday, it's 5 points. Every class day that you don't turn that thing into me, it's 5 points. So if you don't turn it in Thursday, but you wait until Tuesday, then it's Friday, Monday, Tuesday, it's 15 points off. If you wait another couple of days, it's 25 points off. So I would encourage you to do whatever you can to get that project into me by this coming Thursday, okay? All right, today we kind of change gears a little bit. We'll talk about random experiments and counting. Next class we talk about probability, and then the third class from now is about chances and odds. I've grouped them together. They're all kind of the same theme. And then we have our review, and then we have our next test, which is April the 17th. Questions on the calendar? Okay, now let's go to page 27, excuse me, and we'll start at number 1. Can we go to Henry? Yes. Okay, thank you. We'll go to Zach for B. Okay, so we just defined sample space. It's just a list of all the possible outcomes. If you flip a coin, what could you get? Heads or tails. That's a complete list of all the outcomes. If you roll a regular die, what are the possibilities? 1, 2, 3, 4, 5, or 6. That's it. Sample space is just a list of all the outcomes. Next page, number 2. Go to Holly. Okay, so raise your hand if you think you know the answer to how many ways are there to flip a coin and roll a die? How many I don't want the number. I just want to know if you guys have an intuition about how many ways you think there are to flip a coin and roll a die. So I see a couple of hands. All right. So what we're going to do is list them, and then we're going to come up with a formula that tells you exactly how to do this. So what's one possibility for the coin flip? Could be heads. And what's one possibility for the rolling the die? Could be a 1. Heads and 1 seems like a natural place to go. We could still have heads, or 2. Can you guys list? Go ahead. There's not so many. It's kind of annoying, but it's not too annoying to list them all. So list them all, please. Yes. 1 die. Okay, so we've got our complete list, starting with heads 1, going up to head 6, and that's all the possibilities for heads, but just as well we could go tails with a 1, all the way up through tails with a 6. Anybody have any questions about getting the sample space? All right. Justin had asked a good question. This was only 1 die, but if there were 2 dice, do you see that there's a lot more possibilities? It could get up to 12. Yeah, I mean, there's a lot of possibilities with 2 dice. You could get 1, 1, you could get 1, 2, you could get 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3. There's a lot. I'm already tired of talking about them. And imagine I gave you a problem where it was 10 dice and 15 different coins. Can you imagine like how mind-blowingly large the number of possibilities is. The sample space for that experiment is so large that oftentimes we don't want to write them down, but we're going to come up with some nice shortcuts today to figure out how many things are in the sample space without actually listing them all. By counting how many things are in this sample space. There are 12 things in that list. All right, there are 12 possible ways to flip a coin and roll a die. So the question is, can we come up with some nice little shortcut? And the answer is, yeah. What did we do first? We flipped the coin, right? How many possibilities are there for flipping a coin? There are 2 possibilities. Okay, so we've got the coin, and then we've got the die, and there are 2 possibilities for flipping a coin. How many outcomes for rolling a die? 6. Can you think of some nice thing to do with 2 and 6 to make 12? You multiply them. And it turns out this is true in general. If you're doing one experiment followed by another, like flipping a coin and then rolling a die, all you have to do is multiply how many ways there are to do each thing. That will tell you how many ways there are to do them both. 2 times 6 is the 12 that we had up here. So let's get to number 3. Who's our reader now? Are we up to Emma? Okay, so that's the most important thing about counting is that thing right there. Can you guys try in your groups number 4? Just read through each of them, work with each other. So we'll come on back together. And for part A, for 4A, there's a very common misconception that we want to get out of the way right now. We are rolling 2 dice and we are flipping 5 coins. It is very easy to say, okay, the dice, there's 6 possibilities and there's 2 of them, so 6 times 2. And for the coins, how many possibilities for a single coin? 2, and there are 5 of them. This is not the right thing to do. The multiplication rule, or principle, whatever it's called, says you have to list all the different experiments and multiply the outcomes together. So we're going to cross this off and never do that, including on the test. So the first die, how many possibilities? First die has 6 possibilities. Times, always times. The second die has how many possibilities? 6. We're already at 6 times 6. It's 36. It's not 6 times 2. It's 6 times 6. Then we keep going. First coin. How many possibilities for a single coin? 2. Then we have the second coin. And there are 2 of those. You'll list them all out. It's not 2 times 5. It's 2 times 2 times 2 times 2 times 2. Yeah, there's a 5th power happening if you like shortcuts. This is the answer. You need to multiply every single outcome. List them all separately. Jocelyn. Yes. And now I know that number because another group told me. Ashley. So, all right, so do you like the first die as 6 possibilities? Okay, and the second one is another 6. And then we get to the coins. All right, so if you just flip one single coin, it's either heads or tails. That's 2 possibilities, so that's the first 2. But we have a whole bunch of coins. Yeah, 5 times. So we get 1,152 different ways. That's a big number. I don't want to list them all, but I do want to be clear as just a particular example. What might you get on the first die? We'll just make something up. You could get a 2 on the first die. What might you get on the second die? A 4. What might you get on the first coin? Tails, and then nobody else is volunteering, so go ahead. I appreciate how thoughtful you were about the last one. That is one possibility. You roll a 2, you roll a 4, you get tails, heads, heads, tails, heads. That's one possible outcome. There are many possible things that Zach could have said. How many possible things could he have said? 1152. That's all of them. Clearly, we don't want to list them all out, but it's not so terrible to count them if you understand this idea of just multiply every single event separately. Yeah, Becca. Yes? Yes. So if you like shortcuts, and you could say down here 6 to the 2, 2 to the 5, and that is the right answer. I'm reluctant to do that just in general because it's so easy to think if you're doing shortcuts, oh, it's 6 times 2 and it's 2 times 5, which is what a lot of groups did. So I don't like shortcuts until I've written it out a whole bunch of times. So yes, this is the right answer. Okay, let's take a look at B. You go into the restaurant, you got to choose an appetizer. You have to then choose entree, and then finally you choose dessert. And these are all completely separate things, and we're just going to pick one, and then the next, and then the next. And that phrase, and then, is the key that says multiply. Do one thing, and then another thing, and then another thing, you multiply. 5 times 8 times 5. What does that equal to? 200. Thank you. 200 different meals you could get at this restaurant. Let's try part C. Filling out an answer sheet for a test with 3 true, false, and 10 multiple choice questions where there are 4 choices for each question. I would encourage you to write out a lot of stuff. Write out every single question until you see the basic idea, just like we did with the dice and the coins. Give that a shot. We'll come back together in 30 seconds. Okay, let's try this one. The very first true-false question, how many possibilities? 2, true or false? Times. Second true-false question, how many possibilities? Still 2, true or false? Third true-false question, how many possibilities? 2. Now we get to the fun ones, the multiple choice. How many options for that first multiple choice? 4. For the second multiple choice, 4. And a whole bunch of 4s. Ten of these. So if you feel like typing it all in, then you're welcome to. Maybe this is a good time to talk about Becca's shortcut, which Jocelyn just said. Repeated multiplication is better known as exponents or powers. So this is 2 to the 3rd, 4 to the 10. Is that what you said, Jocelyn? Yep. And in some really big number, what does that equal to? 608. Thank you. So if you go into this test completely unprepared and you're going to just guess, you're going to say, oh, it's true, false. So it's only 4 choices on each question. I can guess and I have a reasonable chance at doing something right. How many possible ways are there for you to guess on that test? 8 million and change. Out of those 8 million ways, how many of them are the right answers? 1. There's only one answer key, right? There's just one answer key. So if you're just going to straight guess, you have a 1 in 8 million chance of getting 100. Now, okay, maybe your goals are not 100. Maybe you'd be satisfied with the 75. Still, your chances are not very good. Just as a quick example, this isn't really in the packet, but we'll do it real quick. I'm going to say that there is a 3-question true-false test, just the first part. Just 3 questions, just true-false. Pretend you know nothing about the test, right? You have like a reasonable chance. There's only 3 questions, and they're all true-false. So what I'd like you guys to do is write down 3 T's and or F's. I'm not even going to tell you the questions. I'm just going to tell you to guess right now on my 3-question true-false test. So for example, you could do TFT. Any combination of 3 T's and F's. I'm not telling you the question. Just any place just on the side there. And I just want to know how we do because we're just randomly guessing on the test that you haven't seen. Everybody have 3 T's or F's written? Yes? Okay, so now I will tell you what the right answer was. It was FFT. Raise your hand if you got the right answer. 2 people. Okay, 2 people got it right. Well done. Raise your hand if you got 2 of those right. Check your answers. How many did you get right? Raise your hand if you got 2 right. I see 1, 2, 3, 4, 5, 6. Raise your hand if you, all right, so 2 right, that's what, 67%, that's a D, all right. Raise your hand if you got only one of these right. 1, 2, 3, 4, 5, should have worked harder. That's only a 33%. Raise your hand if you missed them all. Wow, 1, 2, 3, 4, 5, 6. Okay, so by straight guessing on like all the shortest test you could possibly think of, right? Only 3 questions, only true, false. We have 2 people with an A, 5 people with a D, 6 F, and 0% F minus for 6 of you guys. Now, I will say, you guys did a little bit worse than you probably should have done, like just given the straight like laws of probability. I'll give you one more chance at this. Write down 3 T's or F's, different test, and then we'll move on. But I'm hoping we improve because that was a pretty dismal showing, even for not studying. Okay, we ready? Everybody have it? Okay, the right answer this time was FTT. I do, you got to prepare. Raise your hand if you got 100. 1. Raise your hand if you got 2 right. 1, 2, 3, 4, 5, 6, 7. Well done. Raise your hand if you got only 1 right. 1, 2, 3. Ashley, that's improvement. 4, 5, 6, 7. Oh, I thought you missed them. Wait, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then finally none right. 1, 2, 3. Embarrassed people. Okay. All right, that's pretty reasonable right there. You guys know the bell-shaped curve? Do you know that phrase? So it's this kind of curve that looks something like that. Basically says that people are mostly in the middle around the average, and then there are some extremes. There's not very many extremes on the low end and not many on the high end. And I kind of see it here in this 1783. Where were most of you guys? Right in the middle, right? 15 out of 19 of you were in the middle. 1 extreme really good, 3 extremes really low, but mostly in the middle. That's why I was kind of saying the first in purple wasn't so good. Mostly we're in the middle. All right, the point is study. If you could just go in to guess, people say, I really like true false questions. Still very, very easy to like just fail. Okay, let's try part D. We'll get a reader now. Can we go back to Alex? Yep. Any gamblers in the room know what the name is of picking the top 3 horses in a race? Yeah, trifecta. That's it. So this is actually a wager. So if you guys go to the racetrack and say, I want to bet on the trifecta, then you are picking the top 3 horses. Not just the horse you think is going to win, but also the horse you think will be second, and also the horse you think will be third. And if you win, then you win big, because you got to pick 3. What if the horse that you thought was going to be second is really third, and the one you thought was going to be third is really second? Did you win? No, you have to get them in exactly the right order. So it's very particular. Not a good chance of winning, but if you win, you might win a lot of money. Okay, so let's see if we can calculate how many ways there are to do this. We have 3 slots. You have your first horse and your second and your third. How many possibilities are there for the first place horse? How many horses have a chance at winning? 10. All 10 of them. How many horses have a chance of being second place? There's only 9, because that first horse has already crossed the line. That first horse is not going to also be second place. And then finally third, 8. So we multiply 720 different outcomes of this race. Out of those 720, how many is the right outcome, the actual outcome of the race? Just 1. If you pick it, you're going to win a lot of money. But probably you're not going to pick it because there's 720 ways. Only 1 is the right one. Okay, let's go to number 5, and we'll go back to Jocelyn. Okay, now we're going to get kind of this general stuff that we're talking about with these N's and these R's. Before we do that, suppose that I give you a different question. Suppose that there are 10 people taking my math test, and I want to look at the top three scorers. And I want to know how many ways are there for 10 people just thinking about the top 3 scorers on my test. Do you guys see the answer on the board? It's 720, right? Whether it's horses finishing first, second, third in a race, or students finishing first, second, third on a test, it's still the same calculation. It's still 720. So the idea here is that if we can just kind of translate and do something general with this funny N and R business, then maybe we can answer a whole class of problems, not just one specific one for horse races. Okay, so N is the number of things you have to choose from. How many horses did you have to choose from? 10. So in our case, N was 10. And R is the number that you're going to choose as being the ones you're looking at, the special ones. How many horses were special in our outcome? 3. R equals 3. For what it's worth, N is always the bigger one. R is always the smaller one. Okay, so let's keep going around this further. Blake? Okay, so let's pause right there. I said the objects can only be chosen once. If Secretariat is first place, will Secretariat also be third place? No, you're only going to choose Secretariat once. Does the order matter? If Secretariat is first and Seabiscuit is second, how does that compare to Seabiscuit first, Secretariat second? Same or different? Quite a bit different, right? Being first is not the same as being second. So the order in which you let these horses finish matters. You might start to think, well, the order always matters, but suppose I was going to field a basketball team from the athletes in this room. I'm going to pick 5 of you guys to be on my basketball team, 5 guys and girls. If I just pick 5 of you, does the order in which I pick you matter for our basketball team? No, right? I mean, it's just the 5 people going out on the floor. So there, the order does not matter. I'm just picking 5 people and you're all equal. You're all part of the team. But here, the order makes a difference. So if all of those things happen, you can only pick the horse once, the order in which you pick them matters, then it's got a name. It's called a permutation. And it's also got a formula. NPR is just notation. You guys remember what the exclamation point stands for? Or how you say it? It's factorial. And we had a formula for finding the factorials, but we're just going to let the calculator do all the work for us on these. So let's try answering the horse question again, but we'll use the calculator. How much was N in the horse one? 10. And there's this funny symbol with a P, so like the 10 is down below, and there's a P standing for permutation. How much was R? 3. Let me show you guys how to do this on the calculator. First, I'll show you on this calculator. So if you want to type this 10p3 on the calculator, you first type the 10. The P button is buried, so just follow me closely. You hit the button that says math on the far left. Everybody have this screen? Raise your hand if you have one of these calculators in front of you right now. I just want to know who I'm talking to. Okay, just a couple. And from here, hit the left arrow to highlight this thing that says PRB. And then do you see the one that we want? NPR. So either hit number 2 or scroll down and hit enter. And then what was the number that came after the P? It was a 3. And if we do that right, we should get the 720 we got before. If we are on a calculator that looks more like this one, do I have it on this one? I don't think I have it on this one. Okay, if we have a calculator that doesn't quite look like that, I'm just going to walk around and try to help people find it. But basically, you're looking for something that says NPR. Okay, so however you do it, we should get 720. And let's go to 7. I think we're back around to Justin. Okay, so forget permutations for just a second. Could be easy to do. They're new. How many choices do you have for the very first card? 78. Could be any card. Once you've picked that first card, how many choices for the second card? 77. So that's the first card. That's the second card. And all right, I think I've seen the pattern here. The next card has how many possibilities? 76. Okay, so we could just keep multiplying. We're going to go all the way through 10 cards. Can you guys very carefully find out what the last number in this list is? 10th card. A couple of votes said 68. Is that right? Is that the 10th number in the list? Sure feels like it, right? You start with 78. 10 numbers away feels like 68. One vote for 69. Another one for 69. This is interesting. Can we actually count? I'll count on my fingers up here, starting with 78. 78, 77, 76, 75, 74, 73, 72, 71, 70, 69 is the 10th one. It's really easy to go 68 by just subtracting, but that's actually the 11th number in the list if you go all the way down to 68. Okay, so a couple of reasons why you might not want to do it this way. Number one, it's very easy to put the last number wrong if you're not really counting on your fingers. So it is 69. Number two, it's quite annoying to type all those things into the calculator and multiply them out. You're welcome to do it. You'll get the right answer, but it's annoying. So how about instead we use our permutations way? How many things do we have to choose from? 78. How many are we picking to be special? 10. We can just type in 78p10 on the calculator. We'll have our answer. Now it's going to be some very big number. Probably get the E notation there. What is it? 4. So I'll say about 4.6 times 10 to the 18. Quintillion, that was pretty good. Lots of possible readings. Questions on that one? Okay, next page when you're ready. We're going to, did I miss a page? We're going to Doug for number 8. So like picking 5 of you to be on a basketball team, the order in which I pick you makes no difference, right? All equal on the basketball team. There's no first, second, third on the basketball team. Okay, so if we don't care about the order, it's called a combination. We had permutations where the order makes a difference, like first, second, third. Those are all different positions. But then you have like a basketball team, or say a committee. If I wanted to pick 3 of you to be on a committee, does it matter what order I put you on the committee? No, everybody on the committee is equal. So if the order does not matter, if we don't care about the order, it's a combination. Again, there's a crazy formula with factorials. Again, I don't care about it. We've got a button on the calculator. It's going to be very near the one that we just saw before. We'll try number 9 for Ashley. Okay, so this is kind of like just like a runoff type thing. You don't care how you finish in the first race, except you need to be where? You need to be in the top 3. Then you move on, and then we get to the race that counts. But we don't care where you are as long as you're in the top 3. So again, how many horses do you have to pick from? How many have a chance of being in the top 3? There's 10. Any of them could make it there. And how many of them are you actually going to choose to move on? Just choosing 3. But does the order in which they finish that first race matter? No. It says it doesn't matter. So it is not a permutation. It is a combination. Now we're going to type this onto the calculator, but before we do, can you guys think and talk to your neighbors, will this number be more or less than 720, which is how many ways the top 3 horses can finish where we look at the particular order? Is that number right there? The number of ways for the top 3 horses to finish where I don't care about the order, is that more or less than the 720 where I do care about the order? Talk to your neighbors, we'll come back together in a minute. Okay, so I'm hoping we came up with some feeling about this answer, and it should be less than the 720 that we got before. And here's why. Suppose that we had, what did we say? Secretariat was first, and then we'll say Seabiscuit is second, and I don't know, cigar is third. So that's one order, right? Here's another order, Secretariat, then cigar, then Seabiscuit. When we care about the order of the outcomes, are those the same or are they counted differently? If we care about the order, those are different things, right? They're different. These are part of the 720. I don't feel like listing the rest, but that's 2 out of 720 outcomes, right? But if we're doing this modified race and all we care about is who is in the top 3, but we don't care about the order, these are the same outcome, right? I'm just asking you, who's going to get to advance to the next round? Well, it's these 3 horses. I don't care what order you read them in. It's the same second race, right? So they counted separately in the 720. That's 2 out of the 720. But they merge together and become a single same thing in this new count. And in fact, there are a bunch of other ways that are the same here. Seabiscuit, then cigar, then secretariat. That's the same. A lot of them kind of compress down and become the same. So again, not getting buried in the formula, but I just want to let the calculator do the work for me. And so I'll just type it in once here, 10, math, over to PRB, and then 3, and we get 120, a lot less than the 720 we saw before. Okay, there are 3 different ways that I'm going to ask you guys to count stuff on our next test. You might have to use the multiplication rule, you might have to use permutations, you might have to use combinations. So we've seen examples of all of them. Now I want to make it clear, how do you know which one to use? How do we know when it's supposed to be multiplication? How do we know when it's permutations, when it's combinations? Turns out there's a pretty straightforward rule you can follow. It's here in number 10. We'll go to Johannes. Okay, so if you're allowed to pick the same object more than once, it's got to be the multiplication rule. For horse races, can you pick the same horse more than once? No, can't pick Seabiscuit to be first and third. For your true-false test, did you pick the same object more than once? Did you write down more than one T? Yes, and that's perfectly allowed. So if you're allowed to write the same thing twice, like you could write T and then T, you have to use the multiplication rule. What if I want to think about like how many possible phone numbers there are? Are you allowed to use the same digit twice in a phone number? Sure. I hope so too. Probably many of us have the same digit in our phone number. If you're allowed to repeat, you must use the multiplication rule. If you cannot repeat, then you have a second question to ask. The fundamental difference between permutations and combinations was whether or not we care about the order, right? Finishing first, second, third versus top 3. That's the difference. Now I'm going to give you guys a reference sheet that you're going to bring to the next test. It's on the very first page. No, it's not. It's on the second page. It's this. It's a counting flowchart. Okay, first question. You guys have seen flowcharts before, right? Flowchart. Flowchart. Okay, so the first question you ask yourself, we're trying to decide, this is the page 3. It's all the way in the beginning so you can rip it off for the test. You have page 3? Yeah, in the very beginning. Yeah, jump back to page 3 for a second. Okay, the first question, are all the objects different? If they're not all different, it's complicated. We're not getting over there. So to be honest, you can kind of draw a line through that because we're never going to travel that path. So really we've got two questions. Can the same objects be used more than once? If you can use the same object more than once, like true and true, or the same number in a collection of phone numbers, what do you have to use? It's not a combination. If you can repeat, what do you have to use? It's the multiplication. If you can repeat, you must use the multiplication rule. If you can repeat the same t in your true false, if you can repeat the same digits in your phone number, you must use the multiplication rule when you count. But if you can't use the same object more than once, like horses in a race or people on a committee, then you ask the follow-up question. Does the order matter? If the order matters, what do you use? Permutations. That's our yes. Does the order matter? Yes. Use permutations. Does the order matter? No. Use combinations. Those are our three possibilities. So what I'd like to do is give that flowchart a little more context by looking at some specific examples. So let's jump back to page 28. You're going to have that flowchart with you on the test. Probably should have it with you when you're doing the homework. And let's jump down to the bottom of page 29, actually. Okay, so we'll go to part A. Kelly? Okay, first question we ask is about repetition. How do we spell repetition? Is that right? Yeah, I think that's okay. Repetition allowed. We're going to pick six of you to be on our dodgeball team. Am I allowed to repeat the same student twice? No, we're not going to pick the same person twice. We're going to pick 6 different people. Repetition allowed? No. If that answer is a yes, we use the multiplication rule. We're done with the questions. But if it's a no, we have to go to the next question. Does the order matter? If I'm picking 6 of you to be on my dodgeball team, does the order in which I pick you matter? No. And sometimes that's a tricky question to ask. So you do something very specific. Think of like 2 concrete people. So can we say Linda is team member number 1, and Charlie is number 2? That's part of my growing dodgeball team. How does that compare to Charlie being the first person on the team and Linda being second? It's the same team, right? And you wouldn't even know that I picked them first and second unless you saw me do it. But once we got to the court, it's the same team. So the order matters? Nope. Those 2 answers tell me what I'm supposed to do. Is it multiply, permutation, or combination? It's a combination. All right, I think Alex is counting for us. Let us know when you have a total. 21. There are 21 of you to choose from. How many are we choosing in this example? 6 of you are going to be on my team. 21C6 is the answer. I'm actually less interested in what the calculator says is the number. I'm really more interested in the process. Ask the right questions, decide what to do. Technology can get us this enormous number, but really the technology isn't smart enough to know 21C6 is the right thing to do. Questions on that one? I will. Okay, let's try part B. Iris? Okay, you guys have seen a roulette wheel, right? We've got, what are the colors of 1 through 36? Blacks and reds. There's a 0, and sometimes there's a double 0. What color are they? Those are green. And we're going to just spin the ball around and spin the wheel, and the ball will eventually fall into one of those numbered slots. And we're going to do it 3 times in a row, 3 different spins. So the first question, is repetition allowed? I'll abbreviate it here. Meaning, are you allowed to get the same outcome twice? Sure. It could land in 7, and then it could land in 7 again, right? There's nothing saying you can't repeat the same number. I'm not going to repeat the same person on my dodgeball team, but you could get the same number here. And if the answer to that first question is yes, you have to use the multiplication rule. No choice. Close. Okay, so we've got 3 different spins. We're going to multiply 3 numbers together. How many outcomes do you have for the first spin? There are 38 of them. 1 through 36, that's 36 options, or 0 or double 0, total of 38 options. How many options for the second spin? Is it 37? It's still 38 because it could be the same thing again. That's the repetition part. How many options for the third? 38. Okay, yes, it is 38 to the third power. I wouldn't write it that way. I'd probably write it this way and then just type the thing in. Because if you start doing the shortcut thing, you might be tempted to say, oh, 38 options times 3 rolls, and that's not the right answer, right? It's 38 times 38 times 38, not 38 times 3. Questions on that one? Okay, let's try part C. Where are we now, Brittany? Okay, we will ask same question to start. Am I going to repeat the same person in both roles? Probably not. Say no. Don't want to pick the same person to be treasurer and president. That means we have to ask the follow-up question. Does the order matter? So 1 vote for yes, but this can be quite tricky. So we'll play the same game we did with our dodgeball team. I'm going to pick Linda to be president and Charlie to be treasurer. Is that the same or different from Charlie president, Linda treasurer? Very different. And as soon as you put specific names into these hats, you can tell right away whether or not the order matters. This is like first and second place. They're just different positions. Does the order in which you pick them matter? You bet it does, because they're not equal positions. On the dodgeball team, everybody's equal, but these 2 positions are not equal. So the order matters. Justin, is that all right? Okay. What do we use if those are the answers to our questions? Here we use permutations. Oops. How many people do we have to choose from? Still 21. This time, how many are we choosing? Only 2. President and a treasurer. 2 choices. This number is reasonable. It's not too big. But again, I'm not super interested in the actual number. I'm interested in asking the questions, getting to the right thing to type into the calculator. Questions on that? Just the process. Probably on the test, there are going to be two kinds of questions. There are going to be some where I actually want you to find the number, and the number will be small enough to actually like write it down. But there might be others where I say it's okay to leave your answer as a C or as a P. I just want to see the process to get there. Okay. All right. So on the next page is the start of a big old activity called How Many? And it is going to take you guys the rest of the time and probably then some, but let's see how far we can get. We have about 20 minutes. There are answers that follow, and work together as usual.